This is a matching activity where we're looking at atoms and trying to predict chemical formula. To do this, we have to understand the octet rule and valency. Very quickly, we'll remind ourselves that there are 8 groups on the periodic table. For example, group 1, which contains hydrogen. Hydrogen has 1 electron on its outermost orbit. If we were to look at group 5 has 5 electrons on its outermost orbit. Group 8 have 8 electrons on their outermost orbit. To understand and predict chemical formula, you have to understand the octet rule. The octet rule states that an atom is trying to get a full outer orbit. For some atoms, that may mean 2 electrons on the outermost orbit, but for the vast majority of atoms on the periodic table, it means they have to get 8 electrons on their outermost orbit. Okay, so you can see here in the case of hydrogen, hydrogen has 1 electron in its outermost orbit. In other words, it's missing 7 electrons. So it's very far away from meeting the octet rule, unless instead of gaining electrons, it loses an electron. So hydrogen here has a valency of 1 because it's going to lose 1 electron and then it meets the octet rule. Okay, magnesium. This is in group 2. It has 2 electrons on its outermost orbit. So therefore, again, it's quite far away from 8. But if it loses 2 electrons, it'll have a full outer orbit. So therefore, it has a valency of 2. Now, that makes perfect sense as far as, we'll say, group 5. And group 5 are 3 electrons away from the octet rule. So you might imagine to say, okay, so far the number of electrons on the outer orbit has corresponded to the valency. But in this case, it's 3, even though nitrogen is in group 5. But if you think about it, nitrogen has to gain 3 electrons to get to 8, so therefore its valency is 3. You can kind of see where this is going. If we look at chlorine, chlorine is in group 7. It has to gain 1 electron to get a full outer orbit. Okay, so therefore it's going to meet the octet rule. Now we're going to use that knowledge to form chemical formula. So for example, our first compound we're going to try to make is something called magnesium oxide. So we're going to use the periodic table to predict the number of atoms required to make magnesium oxide. So magnesium oxide definitely involves a magnesium, and it involves an oxygen because it's an oxide. Okay, so magnesium oxide, to use the valency for this matching activity, first of all, we look at these boxes here. These boxes represent the valency. Now, if the ratio is the same number, then that means that it is a compound. Okay, so we can see here that in this case, we have Mg and we have O, and we have 2 magnesium is to 2 oxygen. So they're in the same ratio. That means that this is a compound. Okay, magnesium oxide. We can also look at the shapes and see, do the shapes correspond in size? And they do. So therefore, if we look at this, this is definitely a compound of magnesium oxide. Okay, so that is the first compound. The second compound we want to look at is predict the number of hydrogen atoms that are required to make something called ammonia. Now, when you do your research in this, you'll know that ammonia contains nitrogen, okay, and it also contains hydrogen. Okay, now if this is going to create a compound, then we need to make sure we have the correct number of hydrogens that are going to match this. Okay, so we have 1. We can see here that this is not going to fully match what we have here on the left. We have 2. Again, it's pretty close to finishing off this compound, but it's not enough. And we have 3. Okay, so therefore we can see here 3 seems to be a match. Only if the ratio is correct, however. Okay, so when we look at the valency here for nitrogen is 3. It needs to gain 3 electrons to form a compound. And in this case, we have 1, 2, and 3 provided from hydrogen because it's going to lose 3 electrons. So therefore, the ratio is nitrogen is to hydrogen, and it is 3 is to 3. So that is now in the correct ratio for a compound, and this is ammonia. Okay, to be considered a compound, it must have a balanced number of valencies in terms of the different atoms. Okay, So that is the second compound.